Hello, grade 12s. You are welcome to Academic World by Mpakele TL. We are looking at question 9 of Preparatory Exam Gauteng 2025. This question is interesting. It will help you as you prepare for your final exam. And what is this question 9 all about? This question 9, it's about interpretation of a cubic function. Interpretation of a cubic function. When we interpret a cubic function, one of the bigger picture is to find the equation, of a cubic function. When we interpret the cubic function, something very important that we must be able to do is to find the equation of a cubic function. Now, they are very important formula that we normally use when we are looking for the equation of a cubic function. You have to remember this formula that says f of x, if that cubic function is f of x is equals to a into x minus x1, x minus x2, x minus x3. This formula, it's very important when you are looking for the equation of a cubic function if you know the intercepts. So I'm going to say in a bracket, in order for you to use this formula above, you must know the intercepts of this function, of the cubic function f of x. You must know the intercepts. And the x1 and the x2 and the x3, they represent your intercepts. x1, x2, x3, they represent your intercepts. Whereas a is the coefficient of x cubed. I'm referring to the coefficient of x cubed. I will show you what I'm talking about. Now, you see the formula that I'm saying, when we interpret the cubic function, it's important. It's f of x equals to a, x minus x1, x minus x2, x minus 3. This is a very important formula. Or this formula, okay, or let me say we can go for this one. F of x equals to a into x minus x1 squared, x minus x2. We use this one if we know the two intercepts, the two x-intercepts, but one of the intercepts, it is also the turning point. So this one actually is the one that we're going to use when we answer this question 9 of Gauteng. I'm repeating myself. I'm saying this formula, f of x equals to a, x minus x1 squared. It's a highly applicable if one of the x-intercept, it is also the turning point. Look at the graph of f. If you look at the graph of f, the graph of this f of x, the graph that we are interpreting, if you look at the point A, you see that the point A is the x-intercept of f. It is not only the x-intercept, it is also the turning point. That is why we are going to use this formula. When you see the x-intercept, which is also the turning point, you instead of saying x minus x1, x minus x2, x minus x3, you just say x minus x1 squared, x minus x2. We're going to use this formula to interpret our cubic function so that we find the equation of f. Okay? Let's now go and read the question. I'm saying let us go straight to reading the questions and answer those questions, because here they gave you the following properties, but these properties are clear on the graph. Whatever that they are talking about here is clear on the graph. Like they're saying point A is the turning point. We see it. It's here. Point B is the x-intercept. It's here. Point P is a point of inflection. It's here. Point C is the turning point. It's here. Point D is the y-intercept. It is here. So we can go straight now to the reading of the question and start answering the question. So let's go to the reading of the question. The first question says, show that A is 12, B is negative 18, C is 8. Which A are they talking about? Which B are they talking about? Which C are they talking about? They are talking about, remember, f of x is this. It's negative 2x cubed plus ax squared plus bx plus c. This is the f of x which has been given to you. Let me show you. I'm referring to this f of x. It's been provided to you, this one. So your goal now is to find A, find B, and find C. This is your goal. And how do we find A, B, and C? We use this formula to interpret our cubic graph. We use this formula. We say f of x equals to a x minus x1 squared into x minus x2. But now this a here, I'm going to give it a different name, because already on f of x, on the equation of f of x, we already have a here. So let me call this mine k. This k, don't be confused, is the coefficient of x cubed. Is the coefficient of x cubed. Is the number before x cubed. So I'm going to say f of x is equals to negative 2. If you go to this f of x equals to negative 2x cubed plus ax plus b, you see that the coefficient of x cubed is negative 2. So you say negative 2 x minus, you use the x-intercept, which is also the x turning point. So you say 1 squared. Now you say x minus, this x2 is the x-intercept. So what is the x-intercept? It's 4. Now you can expand. Let's start by expanding. Okay, I am out of battery, guys. Let me charge my laptop. Sorry for that. Just be patient with me as I charge the laptop. It is out of battery. And in order for us to continue, it needs to be charged. Hopefully you are enjoying mathematics. Let me, yes, sorted. The laptop is charging. We can continue. Yes, I was saying, let us expand x minus 1 squared multiplied with x minus 4. So I'm going to start with x minus 1 squared, which is the same as x minus 1 times x minus 1. So this one, take this guy, multiply with x, and also multiply with negative 1. So you're going to say x times x, it's x squared. X times negative 1, it's negative x. You do the same thing. Now you use negative 1. Negative 1 times x it's a negative x. Negative 1 times negative 1, it's positive 1, which is x squared minus 2x. Minus x minus x is minus 2x plus 1. So you're going to say f of x equals to negative 2. We have expanded x minus 1 squared. It's x squared minus 2x plus 1 to be multiplied with x minus 4. Now I have to expand, let me write here, I have to expand x squared minus 2x plus 1 being multiplied with x minus 4. Let me write here and say x squared minus 2x plus 1 to be multiplied with x minus 4. So what you do, you can take this x, multiply with everything in this bracket. So you're going to have x cubed minus 2x squared plus x. Now you take negative 4 also, you multiply with everything as well. So it becomes negative 4 times x squared is negative 4x squared. Negative 4 times negative 2x, it becomes positive 8x. Negative 4 times positive 1 is negative 4. So you are having x cubed, you add like terms. Negative 2x squared, negative 4x squared is negative 6x squared. Okay? Plus x plus 8x, it's 9x minus 4. So you've got this now. F of x equals to negative 2x cubed minus 6x squared plus 9x minus 4. Now you distribute negative 2. You multiply everything by negative 2. You say negative 2 times x cubed is negative 2x cubed. You say negative 2 times negative 6x squared is positive 12x squared. You say negative 2 times positive 9x is negative 18x. Negative 2 times negative 4 is positive 8. This is your f of x. Now we can see that the value of a is 12. The value of b is a negative 18. The value of c, it's 8. You have shown it that a is 12, b is negative 18, c it's 8. That's what they wanted. They wanted you to show that a is 12, b is negative 18, c is 8. Now let's go to 9.2. Husserl stated that tangent to the curve of f can be drawn through the point C and D. Validate this statement using an appropriate calculation. So Husserl stated that the tangent to f can be drawn through the point C and D. Tangent to f can be drawn through the point C and D. Validate this statement. Let's go to the graph. Husserl says the tangent to f can be drawn through the point C and through the point D. So let us connect a line through the point C and T. Yes. Husserl claimed that tangent to f can be drawn through the line C and T. Okay, and they say we must validate this statement. First, we must try to know the coordinates of D and C. What are the coordinates of D? D is the y-intercept of F. Do you still remember what is the equation of F? F of X, it was given as negative 2x cubed plus ax squared plus bx plus c. But now because we found the a here to be 12, we'll say plus 12x squared. We found b to be negative 18. Let me write minus 18. We found c to be 8 plus 8. This is the equation of f of x. And I want to use this equation of f of x to find the coordinates of d and also the coordinates of c, because this is where the line pass through. The line which Kusal claimed that it is tangent to f, it is passing through the point D and C. So I want us to know the coordinates of D and also know the coordinates of C. These coordinates are going to be very useful as we solve the problem. So what is the coordinates of D? D is the y-intercept of f, meaning that at D, the x coordinate is 0. At D, x is 0. So we are going to substitute on f of x. Substitute x with 0 so that we can know y when x is 0. Because at D, x is 0. So to find the coordinates of D, we have to substitute on f x, which is 0, to find y. So you are going to, if you do that, you'll find y being 8, which is the y-intercept. Normally, the y-intercept, guys, is this number at the end. This number at the end is the y-intercept of f of x. So the coordinates of D is 0 and 8. How can I find the coordinates of C? C is the turning point, and we all know that to find the coordinates of the turning point, we must do the first derivative. So I'm going to take f of x, which is negative 2x cubed plus 12x squared minus 18x plus 8. I'm going to do first derivative because I'm looking for the coordinates of the turning point. When you derive negative 2x cubed, it's going to be 3 times negative 2, which is negative 6x. This 3 you subtracted by 1 is 2. You say plus. Now it becomes 2 times 12 is 24. X, you subtract 2 by 1, it's 1. The derivative of negative 18x is negative 18. The derivative of 8 is 0, since 8 is a constant number. So when you're looking for the coordinates of a turning point, you do first derivative. Now, f prime x, because at the turning point it is 0, we must equate it to 0. You now say 0 equals to negative 6x squared plus 24x minus 18. Now, this is a quadratic equation which is divisible by negative 6. Divide everything by negative 6. You'll be left minus 6x squared divided by minus 6, it's x squared. 24x divided by minus 6, it's minus 24. 6, 12, I think it's minus 4. So it's minus 4x. Minus 18 divided by minus 6 is positive 3, which can be factorized. 0 equals to, the factors are x, 3, 1, negative, and negative. So the value of x is equals to 3 or x equals to 1. So the x turning point is 1 and 3. We can see that 1 is already at A. It means 3 is the x turning point at C. But now we also have to find the y turning point at C. We have the x turning point at C, it's 3. How do we find the y turning point? We always substitute on the original equation. So the original equation is f of x equals to minus 2x cubed plus 12x squared minus 18x plus 8. Now you say f into 3. You are looking for the y turning point when x is 3. Minus 18 into 3 plus 8. I will have a serious problem here because I don't have a calculator where I am. So, oops, bear with me. 3 cubed is 27. 27 times negative 2 is negative 54. 3 squared is 9. 9 times 12. Ooh, how much is 9 times 12? 12 times 9. 12 times 10 minus 1. 120 minus 12, which is 108. Plus 108. 18 times 3. Negative 18 times 3. 18, 18, 18. 8, 6, 8, 16, 24. It's 54. So it's minus 54 plus 8. So it's 8. Yes, it's 8. So it means that at C, the coordinates is 3 and 8, which is the turning point of F. Now, Kusai claimed that tangent passes through D and C. Tangent, uh, the tangent, which is tangent to F, pass through at the point D and C. So if indeed this line is tangent to F, let's say at C, at the point C, the tangent and the F, they must have the same gradient at C. So what is the gradient of F at C? The gradient of F of the function F at C, we know that it is 0. So we say F prime X at C is 0. That's what we know because C is the turning point. The gradient at the turning point of a function, it's always 0. So this red line, this straight line, which is drawn with a red color here, is only tangent to F at C if they have the same gradient. So I know the gradient of F at C is 0. Let me find the gradient of this straight line, which is where we use the formula y2 minus y1 over x2 minus x1. So if you calculate the gradient there, y2 it's 8, y1 it's 8, x2 it's 3, y1 it's 0. So we see that the gradient is 0. So indeed, this line that passed through D and C is tangent to F at the point C, because the gradient of a line at that point is 0, and also the gradient of F at that point C is also 0. So that the Husserl statement is very valid. It's very valid. So let's answer question 9.3. Believe you me, 9.3, it's so interesting. 9.3, they say the point A, P, and B are joined to form the triangle APB. The point A, P, and B are joined to form the triangle APB. So let us join the point A, P, and B to form the triangle APB. Sorry. Yes, I'm going to join the point A, P, B to form the triangle APB. So this is a triangle APB. Yes, here it's A, here it's P, here it's B. So now they want us to calculate the area of this triangle APB. Now finding the area of a triangle, we normally use the area rule. We normally use the area rule. I want to go for half as keys times base times height, because half times base times height is used in a right angle triangle. So nothing tells me that the triangle APB is a right angle triangle. So I won't use half times base times height. I will use the area rule. Okay. So now here we will need to find the distance of AP and the distance of AB. I will explain why. Okay, actually, I see that we can find the angle here so easy. This angle here. How can we find this angle? We can find this angle using the formula tan theta. Let me write here. Tan theta equals to M. It is easy to find the angle which is formed by the straight line and the x-axis. So if you have got this is an x-axis, guys. So if you have got a line that touch the x-axis or pass through the x-axis, it's easy to find the gradient between that line and the x-axis. So this is the line that touch the x-axis. So we just say tan theta equals to M to find the angle between the x-axis and the line AP. Now, tan theta equals to M. M represents the gradient, which means that we need the gradient of a line AP. But we don't have the coordinates of P. Don't worry, we can find the coordinates of P because they said P is the point of inflection. If you forgot, P is the point of inflection. And the point of inflection can be found by adding the two turning points and divide them by 2. I will say x at A plus x at C divide by 2. I can find the x value of the point of inflection by adding the two x turning points and divide them by 2. So the turning point at A, it's 1. So I will say 1 plus the turning point at C. Don't forget that the coordinates of C is 3 and 8. So the turning point at C, it's 3. 1 plus 3, all divided by 2. So the x point of inflection, it is 2. So we know the x value at P is 2. We have to find the y value. So when you are looking for the y value of the point of inflection, you always substitute on the original equation. The original equation is f of x equals to negative 2x cubed plus 12x squared minus 18x plus 8. So let us substitute x with 2 to find the y coordinate of the point of inflection. Minus 2, 2 cube, plus 12, 2 squared, minus 18 times 2 plus 8. So f into 2, 2 cube it's 8. 8 times negative 2 is negative 16. 2 squared it's 4. 4 times 12, it's 48. 12 times 2 is 24. So it's 48 minus 36 plus 8. F into 2. Okay, 48 minus 36 is 12. 12 plus 8 is 20. Minus 6 is 4. Yes, so the coordinates of P is 2 and 4. So, yes, which means that to find the angle at A, we need the gradient of AP. So we can find the gradient of AP. Let me just erase here. Sorry, guys, I don't have enough space. So to find the gradient of AP, we say y2 minus y1 over x2 minus x1. So what is y2? You can say 4. Y1 is 0. You say 2 minus 1, which is 4 over 1. It's 4. So the gradient of AP, it's 4. So we're going to say tan theta is equals to m. Tan theta is equals to 4. Then you're going to do the second function of tan. So you say theta equals to the second function of tan. I will need to use my phone here. I don't have a tissue, but the phone might help. Second function of tan. Let me check for the scientific calculator on my phone. I need the second function of tan. Shift tan into 4. Yes, it's 75,96. Theta is 75,96. It means that the angle, this angle here, is 75,96. I'm going to call it the included angle of the side AP and AB. So what you guys need to do, you need to find the distance of AP, the length of AP. How do you find the length of AP? You use the distance formula. You're going to say this root of x2 minus x1 squared plus y2 minus y1 squared. So you're going to say 2 minus 1, which is 1, you square it, plus y2 minus y1, it's 4 minus 0, which is 4, you square it. So the answer is square root of 17. The distance of AP, square root of 17. Now the distance from A to B, remember AB is a horizontal line. You don't have to, there's no need for you to use the distance formula. You just have to ask yourself, what is the distance from 1 to 4? We need 3 units to move from 1 to 4. So the length of AB is 3. Now we can be able to calculate the area of this triangle APB because we have got the included angle and 2 sides. You use the area rule. You say half of, you say I have a side AP times I have a side AB. Then you say times sine of the included angle. What is your included angle? It's angle A. So calculating the area of a triangle, you need two sides and the included angle, meaning you need the angle which is between those two sides. So if you look at angle A, is between the line AP and the line AB. And we do have the length of AP, we do have the length of AB, so it's easy to find the area now. You say half of, what is AP? Square root of 17. What is AB? 3. What is angle A? Is 75.96. Then you press your calculator, you will have the area of a triangle APB. It was very interesting. I think the trick here was to find angle A. The rest you can do. So let us go to question. We were at 9.3, now we are at 9.4. For which values of x, it's f concave down. Interesting. For which values of x, it's f concave down. This is a very interesting question. For which values of x, it's f concave down. So I'm going to go to the function f. Let me go to the function f. This is the function f. The point P, don't forget the coordinates of a point P is 2 and 4. And the point P is the point of inflection. So the point of inflection is the point where the graph changes its concavity. So meaning that on the left side, this part, up until the point P, the graph is concave up. Now, from the right side of P, the graph is concave down. So they are saying for which values of x, it's f concave down. So on the right side of the x value 2, this side, the graph is concave down. So this is when x is greater than 2. When x is greater than 2, the function f is concave down. Write down the values of x for which f is strictly increasing. Okay? So to find the values of x where f is increasing, it's easy. Why? I will show you how easy it is to find the values of x where f is increasing. Before I do that, let me remind you that the coordinate of c, it's 3 and 8. Now, if you look at this graph, let's observe it from the left. If we look at it from the left, it's now going down, which means it is decreasing. It is decreasing up until to the point A. And the point A, it starts to increase. So the graph is now increasing up until the point to the point C. From C now, it starts going down. So it means that the function is increasing from A to C. So you say when the value of x is between 1 and 3. So this is when the function f is increasing. Note that I'm not involving equal sign. I'm not saying 1 is less than equals to x is less than equals to 3. This will be wrong because when x is 1, the function is at stationary. When x is 1, at the turning point, the function is stationary, it's not increasing. Also, when x is free, the function is stationary. The function is increasing between the values of 1 and 3. Write down the coordinates of the turning point of h. If h is f of x minus 3, very interesting question. Write down the coordinates of the turning point of h. Okay, they want the coordinates of the turning point of h. H, it is formed by taking the function f of x and shift it vertically 3 units downward. So they say if h is the function f shifted, this minus 3 means we are shifting our function f of x 3 units downward. So what will be the turning point of f? Let's go to the turning, what will be the turning point of h? The turning point of f is 1 and 0, and another turning point of f, it's 3 and 8. But now, if we shift f 3 units down, 1, 2, 3, it will be, the turning point will now be somewhere here. The graph will be something like this. It will turn, the turning point, we will have a new coordinates of a turning point. Let me call this A prime. Let me call it C prime. A prime, I'm referring to the turning point of a H, which is formed by shifting F 3 units downward. So the X turning point will change. At A, the X turning point will not change. At A, the X turning point is 1. So the new turning point is going to be 1. If you shift 0 3 units downward, it's negative 3. The C turning point was free, so the X turning point will not change, will remain being free because the graph is going down. It's not going to the right nor to the left. So the only turning points that change is the Y turning point. It was 8, now it becomes 5. Thank you so much. Thank you for visiting Academic World. God bless you. Any question, please communicate with me. I'm going to end the meeting.